Any questions on the homework that you guys did last night?
I had two. Let me find it real quick. I didn't understand 21 and 22.
Is it this one?
Yeah.
What's the rest of it?
Minus 36x plus 108.
All right, so if you remember how I talked to you guys about how you're now getting to bigger school where this is like, I'm going to teach you, this route, and then in football they taught you this little route, but when you get to high school, you can do either of those routes, and based on the defense, you got to pick which one is the best route to do. Remember me telling you that yesterday?
Yeah.
This problem is exactly why I was telling you that, because I told you a couple ways you can solve this. So like you might have tried to minus the 5 and minus the 5, and you got 0 equals 3x squared minus 36x plus 103. And did you guys watch my factoring videos?
Yeah.
If you tried to do what I told you, which is multiply this times this, you get 309. There's no number that multiply to 309 that adds to 36. So this is not factorable. So it's like I ran into a wall. So it's like, nope, that didn't work. Got to try a different way. So it's like that receiver going, nope, that route wasn't a good route. I need to try a different route. And that happens in higher level math where you try something and it doesn't work. So the other thing is what I can do, and we're going to focus on this today, is let's see if I can make this something squared. Because if I can make it something squared, then I can square root it, and basically I can isolate the x, making it say x equals. So another way we can do it is we can isolate, we can factor, or we can maybe make this become a perfect square and then square root it, and then that gets the x isolated. Does that kind of make sense, Kelly?
Yeah, I just don't really know how to do that with those numbers.
Okay, well the first problem is, Kelly, stay unmuted because you and I are having a conversation.
Okay.
It's just it's just easier. You and I are pretend like we're in class together.
Okay.
So you don't have to keep unclicking and clicking. It's no worries for right now. You and I are talking. The reason that this sucks is this doesn't have a perfect square, does it?
No.
Well, if you watched my videos, the first thing I told you're supposed to do whenever you try to make something or see if it's a perfect square, before you can even do that, is you're supposed to look for a GCF. Do you remember me saying that?
Yeah.
Guess what all three of these have in common?
I'm gonna guess it's 3.
Yep. Now, hopefully you just saw something. When I pulled that 3 out, notice this now has a square root, doesn't it?
Yeah.
It's x. This now has a square root. What is the square root of it?
6.
This times this is 6x, doubled is 12x, ding, ding, ding. This is a perfect square now. But it didn't look like a perfect square in the beginning. Why? Because of a stupid GCF that I had to pull out first. Did that make more sense now, Kelly?
Yeah. So then we would just solve it from there.
Well, now I got this, right? The whole point of this, seeing that this is a perfect square, is to go ahead and factor it. And if I factor it, do you know what it becomes?
X minus 6.
Beautiful. Perfect. Yep. X minus 6 and then squared. And then one common mistake that I'm going to show you that kids try to do is maybe distribute the 3. That is a big no-no, because if I was doing order of operations, I would have to do the exponent before I did the multiplication. So you can't actually distribute that 3. In fact, what you're going to do is, since I'm going to work backwards from here on out, I'm going to get rid of the 3. So it's multiplying by 3. So if I divide both sides by 3, it gets rid of it. I'm trying to get the x isolated or quarantined. I'm quarantining the x. So I get 5/3 equals x minus 6 squared. Are you with me?
Yep.
I square root both sides. Since I put the square root in, I put plus or minus the square root of 5/3 equals x minus 6. Now I add 6 and I add 6 and I get
Sorry, your audio was cutting out for me.
6 plus or minus the square root of 5/3 equals x. And I'm almost finished, Kelly. The only problem that sucks is you were supposed to learn in Algebra 2, you're not allowed to leave a radical in the denominator. And the square root of 5/3 really means the square root of 5 over the square root of 3, and that's no good. So I have to think about fraction work, and I have to think about how to get rid of a radical. Well, how do I get rid of a square root?
You square.
What does that mean?
You multiply it by itself.
Yes. So the reason I'm telling you that is because you can't square this bottom and square the top. That's not fair. Why? Because when we multiply fractions, you have to multiply the top and the bottom by the same number. And if I squared each one of them, it would be like me multiplying by the square root of 3 and the top by the square root of 5. That's not fair. Whatever I multiply the bottom by, you must multiply the top by. So you told me if I square this, it would get rid of it. So I really need to multiply the bottom by the square root of 3. What does it mean I have to multiply the top by?
The square root of 3.
And then what happens when I have the square root of 3 times the square root of 3? It's really the square root of 3 squared. The reason I think of that is it's easier to see that those cancel out, leaving me with just a 3 in the denominator. And then just a couple days ago, I talked about how you multiply things underneath the square root. Since they're both the same, you can actually multiply the 5 times the 3 and make it the square root of 15. So my final answer would be 6 plus or minus the square root of 15 over 3 equals x. And that would be the final answer. All this is side work. All of this is previous stuff from Algebra 1.
Thank you.
Did that make sense, Kelly?
Yeah, I'm going to try to do 22 and see if it makes sense.
And Kelly, that's why you're successful at math, because it's exactly what you should do. Not let me do the next one that's similar to that. Go back and try it. See where you make your mistakes. This is the free time. I love it. Thank you so much. That's awesome. Very good job.
Thank you.
If you need help on that tomorrow or whatever, you can always ask me to do it again. I don't mind going back anytime. If you like, hey, Mr. Martin, I went back and I tried some of those ones that you went over. Can you go back to 2.4 and I'm doing questions from 2.5? I don't mind going back at all, ever. I would love that. All right, that actually leads us into our topic for today. Since no one else has questions. Right, anyone else have questions? I'll give it a second. All right, so for today, if I had, see, this is the problem with this class is I didn't have you when I taught this, but for those of you who did have me, when I did teach factoring, we talked about special cases, and hopefully you watched my videos, and there was one called a perfect square. Well, when I'm teaching you guys to do perfect squares, I'm making that trinomial up myself. I'm coming up with that in my head. So let's talk through how is Mr. Martin making up these perfect squares? Well, when I make the trinomial and I want it to be a perfect square example, what do I first have to make sure that first term has? Do you guys understand what I'm talking about?
Wait, I'm sorry. Could you repeat the question?
If I'm going to make a trinomial example and I'm going to ask you, like, you're pretending you're Mr. Martin and I'm teaching you how to factor something to a perfect square. So I'm making up this example. I'm making up the first, second, and third term for you to factor. How the heck do I make it to make sure that it's something that's going to be factored into a perfect square?
There would need to be an x squared.
What does this first term have to have? Boris, you don't know?
A 1.
No.
X squared.
No. It will have an x squared as part of it. But this front one, if it's going to be a perfect square, this front one has to have a square root. If you watched my video that talked about special cases and factoring, this front number has to have a square root. This back number has to have a what?
Square root.
This number right here has to be a plus sign, and then this times this, the square roots of these two multiplied together, doubled, has to be my middle term. So if Mr. Martin is coming up, I'll just do one for you. If I'm coming up with an example, I go 4x squared. Okay? Why did I choose 4x squared? Because this number has a square root. What is it? 2x. So I kind of think of this in my brain. That's in my brain, that the square root of that is 2x. And then I go, okay, let's make another number that has a square root, 9. And I go, okay, the square root of that is 3. And then the way I come up with the middle number is I go, this times this is 6x, doubled is 12x. And so this is what I put on your paper. And I say, factor that. And then I know the answer is supposed to be 2x plus 3 squared. I make these up in my head. And the process that I showed you is the way I did that. So.
Wait, how did you get 12?
3 times the 2x is 6x, doubled is the 12x.
Oh, okay.
If you're having a hard time, I'm going to keep saying this, and I don't know how to keep telling you this. You need to watch the special cases video on factoring, and you need to understand factoring big time. It's not going away, and we're going to use it in a different way today. So, I'm giving you the front number. I'm giving you the back number. What would be my middle number?
$24.
How did you get that?
The square root of 9 is 3.
Careful,
careful.
careful.
X.
Thank you.
9x squared. The square root of 9x squared is 3x.
Beautiful.
Square root of 16 is 4.
Perfect.
Multiply them together and then double it. You get 24.
Now, does it matter the sign? It's 24x. Does it matter the sign? No. If I put a plus sign here, this is going to factor into 3x plus 4 squared. Notice it's a squared right here. Something times itself 2 times. If I had made it this one, what would be the only difference?
It's 3x minus 4 squared.
Exactly. These are called perfect squares. Now, what if I gave you this? What if I needed this back number? Well, how was the middle number made?
By multiplying the first and third number and then doubling them.
So it was the square root of the first and the square root of the third number multiplied together and then doubled. Yes? Perfect, Kelly. Now, Kelly, what if I was going backwards because I know I have 12x? What would I do to go backwards?
Divided
By what?
by 2x.
By just 2. Because remember, I doubled it. So if I divide it by 2, I get 6x, yes?
Yeah.
How was that 6x supposed to be made? By multiplying the square root of this number times the square root of this unknown. This is my question mark. You with me?
Yeah.
Well, what's the square root of this? I know that. What's the square root of 4x squared?
2x.
So the 2x times what gets me to 6x?
3.
3, right? But this is not my missing number because remember, this isn't what's here either. The square of this is here. So what is down here?
9.
That's called completing the square. That is a process that will help us in just a second. That is called completing the square. That is what we are going to do today for the rest of the class. So, to give you an example, please make sure you're listening to my whys and all that kind of stuff. They are super, super important on how we handle these things. All right, so one way that we've talked about how we can solve for x is called isolation or quarantining the x. How come I cannot quarantine the x in this problem. Not the way that it is right now.
There are two x's.
Two x's.
There are two types of x's. So the way that it is written right now, I cannot get the x by itself. Not by just adding 11. Nope, that's not going to work. Do you guys understand?
Yeah.
Then I try to factor. I can solve by factoring. That's a way. Well, Mr. Martin, if you followed my videos, this should tell you different signs, and this says subtract. I need two numbers that multiply to 11 but subtract to 6. There are no two numbers that multiply to 11 but subtract to 6. So factoring doesn't work. So there's this other process that we talk about that's called completing the square. That's a way that we can possibly solve equations. And the way that I do that is I go, first off, I say, you know what, 11, you're not helping me out. I'm going to move you to the other side. Now, one thing you're supposed to understand in math is you are legit allowed to add whatever you want to one side, as long as you add it to the other. So do you remember that example I just gave you where I gave you the first term and the middle term, and you were supposed to find my last term? Do you guys remember that?
Yeah.
Doesn't this problem now look very similar to that when I write it like this and I have a missing term back here? How could I figure out what number would go back here to make this whole trinomial a perfect square? That's my goal. What number is missing here? Well, how did we figure that out? What did we do to the middle number first?
Divided by 2.
Which is 3x, yes?
Yeah.
How did I make the 3x? It was the square root of this number, which is x, times the square root of this number, which is my unknown. So through x times what would get me to 3x?
3.
3, but remember, 3 is not the missing number because I have to square it. So what number is missing?
9.
So I have plus 9. Is that okay to just randomly throw a plus 9 on this side of the equation? Yes, as long as I do what?
It to the other side.
As long as I add 9 to the other side, I'm Gucci.
So it'd be equal to 20 then?
Yes. But what can I now make this look like? The whole purpose of me writing it as a perfect square was so that I can actually factor it so that it's a perfect square. So I'm actually going to kind of solve it by perfect square. So I am actually going to solve this by factoring and by isolating. It's kind of a combo platter, but it's this process called completing the square. So what is this going to turn into? I don't want to write it like this as a trinomial.
X minus 3.
Good. X minus 3. Very good, Orest. Robert, does that make sense?
Yeah, I was about to say that.
Perfect. Now what can I do? Now I can get this x by itself by, what can I do to get rid of the squaring? Dominic, you with me? Yes, Kelly, you're right. Dominic, you there?
Yeah.
You guys don't have to be so fast to unclick and click, because when you do that, it does not catch what you're telling me. So relax, it's okay. Click the unmute, talk to me, and then click the mute again. Dominic, do you understand that squaring and square rooting are opposites? So if I square root this side, this cancels out.
Yeah.
Now, if I square root one side, what do I have to do, Dominic?
Square root the other side.
Now, who put the square root sign in there?
So what?
Who put the square root sign in there?
We did. So we have to
Why-
put it on the.
Why am I asking that? Dominic, do you know why I'm asking that? No. If I put the square root sign in, meaning I did it to undo a squaring, you must put plus or minus sign. That's why that's coming there. Some of you guys just think that I pull stuff out of my rear end, and it's not. There's a purpose. The reason I put the plus or minus is because I put this square root in here. So now I have the plus or minus square root of 20. How do I finish this off? Samantha, how do I finish this problem off? Tucker, how do I finish this off? Very good, guys. You add 3 to both sides. Now, I've actually been done with the Algebra 2 for a while, but I'm not finished with this problem because this is not simplified. You must simplify this. For those of you, again, this is tough because I showed them how I simplify this.
It's
I
2,
take
5,
the
right?
20. Huh?
2 times the square root of 5.
Yes. You already went ahead of me. I love it. Oris, good job. This is 4 times 5. This turns into 2 times 2. If you don't know how I'm doing this, you need to watch a video. I can look it up for you. Or I can maybe stay with you after or something. But there is a video that shows how I do this. This becomes 2 squared times 5. And there's a imaginary 2 here. How many times does 2 go into 2? Once, so I get a 2 out. Square root of 5. So my final answer is x equals 3 plus or minus 2 square roots of 5. This is a welcome to 2 algebra 2 problem because there's so much crap from everything that I've taught before that's combining into one problem to get me to this answer. By the way, there's 2 answers. One is 3 plus 2 square roots of 5, and one is 3 minus 2 square roots of 5. And if you wanted to like get an approximation of this, you'd put in your calculator a square root of 5. You'd hit equals. You get some number that would be a decimal and long forever. Keep that number in there. You would then hit times 2. There would be a new number. You would then add 3 to that, and that would get you your first answer. This one's a little trickier. What I would do is I would hit the square root of 5. I would then hit times 2. I would then actually hit 3 and then the minus sign. And then on these scientific calculators, there's this thing called the answer button. I would click answer, and what the calculator would do would store this answer for me, and then I could take 3 and minus it. You would not want to hit after this minus 3, because then that would be the answer minusing 3, which is a total different question than 3 minus it. It would be like me saying 3 minus 2 and me doing 2 minus 3. Those are not the same problems. I hope I make sense on that. Noah, we can talk after, yes. Can you unmute Noah?
Yeah, I can.
Okay. It's better to just talk like that. We'll talk after class.
Got it. Thank you.
Any questions on what I just did?
Would you be able to do
No.
another problem where we use factoring?
Oh, for sure. Absolutely. Kelly? Did you have a question?
No.
Robert, I love that you are talking with me. I appreciate it. This is how you're basically a model student. I'm going to keep using you so other people want to know how they're going to be successful. It's going to be like being you, man. Same with you, Kelly. Same with Horace. You guys that are talking. That's how you guys are going to be successful if you keep working like that. Right here, Robert, do you see how, did you watch my videos, Robert?
No, I didn't have time to get to it yesterday.
Okay.
So watch them after.
Get to it as soon as you
today.
can, because if you're not going to understand the way I'm talking right now. But right here, I try to solve this by factoring. And if you watch my videos, you're going to understand this. This says sign rules, and this tells me that these are same, and I'm going to add. So I need 2 numbers that multiply to 3, but add to 2. And when I look at that, 3 times 1 is the only way to get to 3, and 3 plus is 4. So meaning this is not factorable. So I've run into a problem. My problem is this isn't factorable. So I'm going to go, oh, Mr. Martin just showed me a new way to try this problem. It's called completing the square. So I'm going to move the 3 over. And then I'm going to do this. And I'm going to kind of say, hey, if I add something into this, can I make this become a perfect square? But if I add that number over here, all I have to do is add it here and I'm good. Does that make sense?
Yes. So would that be 4?
No, I remember I take half of that, so it's x.
Oh, that's right. Okay.
And then I say this square root of this is x. What times x would still get me to x would be a 1. If I square 1 to put it back down here, it's just a 1. So I
Okay.
actually just add 1 to both sides. And when I do that, I get negative 2 equals. And then again, the purpose of this is to make it written so I can write it like this. The reason that's cool is because then I can square root both sides and isolate x. Old stuff is coming back to bite you. As soon as I see that, I know that that's I. And since I put the square root in, it's going to be plus or minus. So it's plus or minus I square roots of 2 equals x minus 1. I add 1 to both sides, and I get 1 plus or minus I square roots of 2 equals the x. And that's my final answer.
Okay.
Do one more. I'm going to try to do it fast because I think maybe more examples you can watch it later on or whatever. Again, this would tell me same signs. I need two numbers that multiply to 8, but add to 4. There is nothing, so it's not factorable. So I go, okay, let's try that completing the square. What do you notice about the middle term, Robert? Since I'm going to divide by what number? What kind of middle number do I want this to be if I'm going to try this process?
An even?
Right, it's going to be much easier. If that's an odd, I'm probably not going to try completing the square.
Yeah.
Because it's not going to be a nice, pretty number. And I only want to do things that make my life easy. So because this is a 4, I'm going to say, hey, let's try to complete the square. Divide by 2. This turns into 2x. This is an x. That means I'm missing 2. Square it. That means I need a 4. If I add 4, I got to add 4 to this side.
So it'll be negative 4 equals 2.
Equals x plus 2 squared. Square root both sides. Plus or minus. As soon as I see that negative, I pull out an I. The square root of 4 is actually 2, so it's just 2i equals x plus 2. I then minus 2 to both sides. These do not combine over here. They're not like terms. So it's just negative 2 plus or minus 2i equals x. And that is a perfectly acceptable answer. That's what I was telling my kids. You know, 49 is not going to be the answer, or a 2. You know, it's not going to be whole numbers. It's going to be nasty stuff in Algebra 2.
Okay. Thank you.
Is that making sense now?
Yeah, that cleared things up, and I'm definitely going to watch those videos later.
Factoring videos will help you understand everything in the way I talk.
All right. Thank you.
You're welcome.
Have a good
Bye,
day.
guys. Have a good day.
Have a good day.
Noah, you can stay after. I'll chat with you real quick.